Now let's understand what exactly natural language processing is. Now, natural language processing is a component of text mining which basically helps a machine in reading the text. Obviously, machines don't actually know English or French, right? They interpret data in the form of zeros and ones. So, this is where natural language processing comes in. NLP is what computers and smartphones use to understand our language, both spoken and written language. Now, because we use language to interact with our device, NLP became an integral part of our life. NLP uses concepts of computer science and artificial intelligence to study the data and derive useful information from it. Now, before we move any further, let's look at a few applications of NLP and text mining. Now, we all spend a lot of time surfing the web. Have you ever noticed that if you start typing a word on Google, you immediately get suggestions like these? This feature is also known as autocomplete. It will basically suggest the rest of the word for you. And we also have something known as spam detection. Here is an example of how Google recognizes the misspelling Netflix and shows results for keywords that match your misspelling. So, the spam detection is also based on the concepts of text mining and natural language processing. Next, we have predictive typing and spell checkers. Features like autocorrect, email classification are all applications of text mining and NLP. Now we look at a couple of more applications of natural language processing. We have something known as sentimental analysis. Now, sentimental analysis is extremely useful in social media monitoring because it allows us to gain an overview of the wider public opinion behind certain topics. So basically, sentimental analysis is used to understand the public's opinion or customers' opinion on a certain product or on a certain topic. Sentimental analysis is actually a very huge part of a lot of social media platforms like Twitter, Facebook. They use sentimental analysis very frequently. Then we have something known as chatbot. Chatbots are basically the solutions for all the consumer frustration regarding customer call assistance. So we have companies like Pizza Hut, Uber who have started using chatbots to provide good customer service. Apart from that, speech recognition. NLP has widely been used in speech recognition. We're all aware of Alexa, Siri, Google Assistant, and Cortana. These are all applications of natural language processing. Machine translation is another important application of NLP. An example of this is the Google Translator that uses NLP to process and translate one language to the other. Other applications include spell checkers, keyword search, information extraction, and NLP can be used to get useful information from various websites, from Word documents, from files, and etc. It can also be used in advertisement matching. This basically means recommendation of ads based on your history. So now that you have a basic understanding of where natural language processing is used and what exactly it is, let's take a look at some important concepts. So firstly, we're going to discuss about tokenization. Now, tokenization is the most basic step in text mining. Tokenization basically means breaking down data into smaller chunks or tokens so that they can be easily analyzed. Now, how tokenization works is it works by breaking a complex sentence into words, right? So you're breaking a huge sentence into words. You'll understand the importance of each of the word with respect to the whole sentence, after which you'll produce a description on an input sentence. So for example, let's say we have this sentence, tokens are simple. If we apply tokenization on this sentence, what we get is this, right? We're just breaking a sentence into words, then we're understanding the importance of each of these words, right? We'll perform NLP process on each of these words to understand how important each word is in this entire sentence. For me, I think tokens and simple are important words. R is basically another stop word. We'll be discussing about stop words in our further slides. But for now, you need to understand that tokenization is a very simple process that involves breaking sentences into words. Next, we have something known as stemming. Stemming is basically normalizing words into its base form or into its root form. Take a look at this example. We have words like detection, detecting, detected, and detections. Now, we all know that the root word for all these words is detect. Basically, all these words mean detect. So the stemming algorithm works by cutting off the end or the beginning of the word and taking into account a list of common prefixes and suffixes that can be found in any word. So guys, stemming can be successful in some cases, but not always. That is why a lot of people affirm that stemming has a lot of limitations. So in order to overcome the limitations of stemming, we have something known as lemmatization. Now, what lemmatization does is it takes into consideration the morphological analysis of the words. To do so, it is necessary to have a detailed dictionary which the algorithm can look through to link the form back to its lemma. So basically, lemmatization is also quite similar to stemming, right? It maps different words into one common root. Now, sometimes what happens in stemming is that most of the word gets cut off. Let's say we wanted to cut detection into detect. Sometimes it becomes det or it becomes tect or something like that. So because of this, the grammar or the importance of the word goes away, right? You don't know what the word means anymore due to the indiscriminate cutting of the word. Sometimes the grammar or the understanding of the word is not there anymore. So that's why lemmatization was introduced. The output of lemmatization is always going to be a proper word. Okay, it's not going to be something that is half cut or anything like that. Right? You're going to understand the morphological analysis and then only you're going to perform lemmatization. An example of a lemmatizer is you're going to convert gone, going, and went into go. All the three words anyway mean the same thing, so you're going to convert it into go. We are not removing the first and the last part of the word. What we're doing is we're understanding the grammar behind the word, we're understanding the English or the morphological analysis of the word, and only then we are going to perform lemmatization. That's what lemmatization is all about. Now, stop words are basically a set of commonly used words in any language, not just English. Now, the reason why stop words are critical to many applications is that if we remove the words that are very commonly used in a given language, we can finally focus on the important words. For example, in the context of a search engine, let's say you open up Google and you try how to make strawberry milkshake. What the search engine is going to do is it's going to find a lot more pages that contain the terms how to make rather than pages which contain the recipe for your strawberry milkshake. Now that's why you have to disregard these terms, right? The search engine can actually focus on your strawberry milkshake recipe instead of looking for pages that have how to and so on. So that's why you need to remove these stop words, right? Stop words are how, to, begin, gone, various, and the. All of these are stop words. They are not necessarily important to understand the importance of the sentence. So you get rid of these commonly used words so that you can focus on the actual keywords. Another term you need to understand is document term matrix. A document term matrix is basically a matrix with documents designated by rows and words by columns. So if your document 1 has this sentence, this is fun, or has these words, this is fun, then you're going to get 1, 1, 1 over here. In document 2, if you see, we have this and we have is, but we do not have fun. So that's what a document term matrix is. It is basically to understand whether your document contains each of these words, right? It is a frequency matrix. That is what a document term matrix is. Now let's move on and look at a natural language processing demo. All right, so what we're going to do is we're going to perform sentimental analysis. Now, like I said, sentimental analysis is one of the most popular applications of natural language processing. It refers to the process of determining whether a given piece of text or a given sentence of text is positive or negative. So, in some variations, we consider a sentence to also be neutral. That's a third option. And this technique is commonly used to discover how people feel about a particular topic or what are people's opinions about a particular topic. So, this is mainly used to analyze the sentiments of users in various forms, such as in marketing campaigns, in social media, in e commerce websites, and so on. So, now we'll be performing sentimental analysis using Python. So, we are going to perform natural language processing by using the naive Bayes classifier. That's why we are importing the naive Bayes classifier. So, guys, Python provides a library known as Natural Language Toolkit. This library contains all the functions that are needed to perform natural language processing. Also, in this library, we have a predefined data set called movie reviews. What we're going to do is we're going to download that from our NLTK, which is Natural Language Toolkit. We're basically going to run our analysis on this movie review data set. And that's exactly what we're doing over here. Now, what we're doing is we're defining a function in order to extract features, right? So this is our function. It's just going to extract all our words. Now that we've extracted the data, we need to train it. So we'll do that by using our movie reviews data set that we just downloaded. We're going to understand the positive words and the negative words. So what we're doing here is we're just loading our positive and our negative reviews. We're loading both of them. After that, we'll separate each of these into positive features and negative features. This is pretty understandable. Next, we'll split the data into our training and testing set. Now, this is something that we've been doing for all our demos. This is also known as data splicing, right? We've also set a threshold factor of 0.8, which basically means that 80% of your data set will belong to your training and 20% will be for your testing. You're going to do this even for your positive and your negative words. After that, you're just extracting the features again, and you're just printing the number of training data points that you have, right? You're just printing the length of your training features and you're printing the length of your testing features. We can see the output. Let's run this program. So if you see that we're getting the number of training data points as 1600 and your number of testing data points are 400. There's an 80 to 20% ratio over here. After this, we'll be using the naive Bayes classifier and we'll define the object for the naive Bayes classifier, which is basically classifier, and we'll train this using our training data set. We'll also look at the accuracy of our model. The accuracy of our classifier is around 73%, which is a really good number. Now, this classifier object will actually contain the most informative words that are obtained during analysis. These words are basically essential in understanding which word is classified as positive and which is classified as negative. What we're doing here is we're going to review movies. We're going to see which movie review is positive or which movie review is negative. Now, this classifier will basically have all the informative words that will help us decide which is a positive review or a negative review. Then we're just printing these 10 most informative words. We have outstanding, insulting, vulnerable, ludicrous, uninvolving, astounding, avoids, fascination, and so on. These are the most important words in our text. Now, what we're going to do is we're going to test our model. I've randomly given some reviews, right? If you want, let's add another review. We'll say, I loved the movie. So I've added another review over here. Here we're just printing the review and we're checking if this is a positive review or a negative review. Now let's look at our predictions, right? We'll save this and I forgot to put a comma over here. Save it and let's run the file again. So these were our randomly written movie reviews. The predicted sentiment is positive. Our probability score was 0.61, right? It's pretty accurate here. Now, this is a dull movie and I would never recommend it, is a negative sentiment. The cinematography is pretty great, right? That's a positive review. The movie is pathetic, is obviously a negative review. The direction was terrible and the story was all over the place. Now, this is also considered as a negative review. Similarly, I loved the movie is what I just inputted and I've got a positive review on that. So our classifier actually works really well. It's giving us good accuracy and it's classifying the sentiments very accurately. So, guys, this was all about sentimental analysis. Here, we basically saw if a movie review was positive or negative. So, guys, that was all for our NLP demo. I hope all of you understood this. It was a simple sentimental analysis that we saw through Python. So, again, if you have doubts, please leave them in the comment section and I'll help you with all of the queries. So, guys, that was our last module, which was on natural language processing. Now, before I end today's session, I would like to discuss with you the machine learning engineers program that we have at Edureka.